All right, guys. So what I want to do here now is using the same problem we've been working on, adding new things to. I want to add what's known as a percentage yield to this problem and see if we can deal with it. Now, percentage yield is really, really simple, you guys. One way of thinking about percentage yield is, well, if I scored 92 out of 100 on this last test, then my percentage yield would be 92 divided by 100. My answer times 100 would be 92%, right? So I get a 92% yield. And so that's, the score you get on the test is, another way of thinking about your percentage yield. So what I want to do is add in a percentage yield to this problem right here and then go ahead and solve it. So what we're given is that we got 23 grams of hydrochloric acid. So we got 23, why are you not writing? Boom. 20, there we go, 23 grams of that guy. And we're trying to figure out how many grams of water. So how many grams of water? And I think I worked this problem for you guys once already. But what I'm going to do is I'm going to add in one more piece to it, and that is, what the percentage yield in chemistry is telling you is that, on paper, reactions always happen with 100% yield. Whatever's on the left moves over onto the right. But in the real world, it doesn't work that way. And so things get in the way, right? The real world gets in the way. And so we never have 100% yield. So very commonly, you'll be given a percentage yield. Now, what I tell my students to do is write it on top of the arrow. So let's say this equation right here, this reaction has only a 79% yield. And so what I train my students to do is write it on top of this arrow, and you'll see why. So I'm going to write up here 79%. Okay, so what we're going to do is we're going to ignore the percentage yield for now. We're going to work the problem. How many grams of H2O can we make from 23 grams of HCl? I forgot to balance this equation. We might want to balance it really quickly. I'll use a different color to balance it. So I think it balances with a 3 here and a 1 here and a 3 here and a 1 here. Okay, coming back to my red, I'm going to change this guy to moles, so that's 36.5 grams of HCl in 1 mole of HCl. And then I'm going to go from moles of HCl to moles of water, which is a 3 and a 3. So I'm going to go 3 and 3. And then I'm going to go from moles of water to grams of water, which is 18 grams per 1 mole using the molar mass of water. And then now I've got my stoichiometry done, but now before I finish and do my math here, I just want to ask myself one last question, which is, does the reaction have a percentage yield? And oh my gosh, yes it does. And it's almost always given to me in the problem. If there is a percentage yield, and it says, yeah, this thing has 79% yield. Well, if I do this math right now, then I'm assuming the reaction has 100% yield, that everything that was on the left works its way over onto the right. And so the very last step I have to consider is if I have a percentage yield. Now, if I have a percentage yield, and I'm moving left to right, which is what I'm almost always doing, I'm going to multiply by my percentage yield in its decimal form. So in this case right here, what I'm going to do is multiply by 0.79 as my last step. Now, if in fact, I'll do this in another color, I was moving the other direction, right? So instead of knowing a reactant and trying to figure out a product, if I knew a product, let's say I knew this guy, and I was coming backwards to find this guy, then if I'm crossing the arrow going in the reverse direction, you guessed it, I'm going to divide by the percentage yield. So if I was going from aluminum chloride back to aluminum hydroxide, then instead of this 0.79 on top up here, what I would have is 0.79 on the bottom down here. And I'd be dividing by 0.79. But in fact, that's not what we're doing. So in order to avoid confusion, I'm just going to erase that because that's not what we're doing. All right, we're back to red. And so most of the time I'm going in the forward direction. So most of the time I'm going to end up multiplying by the percentage yield. So I'm just going to do that, add that into my math, and we'll see what we get. I think my calculator is going to be helpful here. 23 times, I got a 3 on top, I got an 18 on top, and I got a 0.79 on top. And then I'm going to divide that by everything on the bottom is a bunch of ones. There's a 3. And I'm going to divide by 36.5. And when I do that math, I get about 8.96 grams equals 8.96 grams of H2O. I forgot to cross my units off. That crosses off. That crosses off. Moles of H2O crosses off. My final units, grams of H2O. And there it is, you guys. There's my answer. Okay, so that's how you handle a percentage yield. Most of the time you're going to see that moving left to right, so you're almost always going to multiply by the percentage yield. If you are going right to left, then you have to divide by it. Now here's the interesting case. I'll do this in the last color here. What if I was moving from this guy to this guy? So I'm not crossing the arrow. And the answer is, you guessed it again, the reason that we write the percentage yield on top of the arrow is because it only matters if we cross the arrow. So if I'm going from a reactant to another reactant, don't care about the percentage yield. If I'm going from a product to another product, guess what? Don't care about the percentage yield. So it's only when I'm going across the arrow, and that's why I always have you guys write it on top of the arrow. Okay, there you go. Good luck with other percentage yield problems when you run into them.